that in the last class we were discussing about this iterative methods for solving initial value problem, and there we learned this Picard's method, Taylor series method, and Euler's method. Like Euler's method is like Taylor's first order methods. So like we can like how this Euler methods come into existence like this. So we have this as a initial value problem. Dy by dx equals to f of x comma y, and with this initial condition. So we want to solve this initial value problem using Euler's method. So the development of this method is like this. If suppose this is the original solution, this curve. If this curve is the original solution, and this is your x naught point at L, and this is the y naught. So the information is with you is this y naught and this x naught, and someone want the value of the function at this point x naught plus nh. So to calculate the value of x naught plus nh, what we do first, we divide the interval from x naught to x naught plus nh into n subintervals, and then we can see the first interval x naught to x naught plus h. That is, this one is our x1. So now we want to know what is the value of y at x1. So this we want to know, and you can see that this value is L1 to P1. If you see, this value is L1 to P1. But instead of calculating this value L1 to P1, we get some approximated value like this. So this is like y1, this is L1 P1, and then you can write this L1 P1 because up to this point is this is P. So if you draw a parallel line to the x-axis, then you have this line P R1, this line you have. So it means this is also the point or length equal to L1P, and then we have P1 R1. Okay, they have taken another point like L1 R1 actually equals to LP because this line is parallel to x-axis. So L1 R1 is equals to LP, and then plus R1 P1 or P1 R1. Then they have approximated this P1 R1 because this P1 R1 actually should be tilt curve, but it is not tilt curve. This P1 is actually, we are drawing a tangent at the point P, and then somewhere like below the curve this P1 is exist. So if this angle is like a theta, the angle between P1 and PR1, if theta, then the length this P1 R1 is equals to PR1 tan theta, because you know that tan theta is equals to this one P1 R1 upon PR1. So P1 R1 from this point, from the not like from the curve. So P1 R1 is equals to PR1 tan theta. So instead of getting the exact solution, we are trying to get an approximate solution, which is like giving the approximate y1, which is like equal to like approximated to y of x1. So we are calculating y1 according to this strategy. Like whatever point is given to us, we draw a tangent, and then we take this point x naught h, and where this the perpendicular line at the x naught h intersecting with this point, we'll we assume that this one is our approximated of value of yx1, that is y1. So, and this tan theta we can we know that this can be rewritten as dy by dx because the slope. So we can write like this: dy by dx at the point P. And what is P point? P point is your x naught, y naught. And then you know that as per our given initial value problem, dy by dx equals to f of xy. So it is like f of xy at the point P. So we have substituted the value of x and y, x naught p1. So this is the our method. So now we have value at approximated value y1 for this. For, like this is approximation to this y of x1. Next, from this point y1, we again draw a tangent, and then the tangent again intersecting somewhere with the line perpendicular at this point x naught plus 2h, and then we approximated the value of y2 at the point x2. X2 is your again x naught plus 2h, which will be given by this. So in this way we can get the value of yn, that is x naught plus nh, equals to y of n minus 1 plus h into f of x n minus 1 y n minus 1. Or for the next point, like if you want like this, at this point x naught plus n plus 1 h, then it is given by this. So this is like a general form of the Euler's formula. So we'll see this like this. So like for first iteration, like we have x naught and this is x naught plus h. Then this is the point you say P, and this is we have taken as R1. So like we are instead of writing this value, we are approximating this value to by this value. So we are getting this as a y1, and this is the error between the yx1 and y1. This is the error because we are drawing a tangent and drawing a line perpendicular to x-axis at the point x naught h, and where this tangent and this perpendicular line intersecting, we are assuming this is the approximate value of y at x1 and this. So here you know that as h, if you take h is small, then the error is less. So if you take less values of h, then you have less error in the approximated value of yx1. And in this way, like we go further also like this. You can see that if this is our actual solution, then we draw some tangent and that we will get this. This is like our, supposing this one is a, if our like a true solution, and then we are at first point we draw a tangent and where it is intersecting to the perpendicular line at x naught plus h, this is our like y1. Then again from this y1 we draw the tangent and it is intersecting the point at y2. So we are getting, so these are the error we are neglecting at each and every step. So this is the way we'll go for each and every step in Euler's method. So now we have to use Euler's method to find the approximate value of y corresponding to x equals to n, given that this one is equal to this one. So this is x plus y, and this is actually our f of xy. So here like you have to calculate value at this point x equal to 1. Initially the x naught is 0 given here and y naught is 1 given here. So first we identified this x naught and y naught, and then we divide the interval from 0 to 1 into n subintervals. So if you take n as a large, like if you taking n as a 10, you are getting h equals to 0.1. And if you take n is equals to 100, then h is small. So if you increase the number of sub-intervals between x equal to 0 to x equal to 1, your like approximated values are more accurate. For simplicity, we have taken as n as 10, and if we are taking n as 10, we are getting h as 0.1. So now this one is our actually f of x y, or you can say like instead of this I write suffix also, f of x and comma y. So initially, like when n equals to 0, we know that what is our x naught. X naught is our 0. What is our x? Sorry, what is our y naught? Y naught is also given. This one is y 1. And then we required f of x naught y naught. So f of x naught means you substitute x equals to 0, y equal not equal to 1, you are getting 1. And then you are calculating y1 using your Euler's method, that is y naught plus h of x naught y naught. Instead of this, you can, because it is a nh, it means it is xn. So y naught plus h of f xn yn. So it means that for y1 it is y naught plus h f of x naught y naught. Y naught is 1, h is 0.1, and f of x naught is 1. So we have substituted, we have this one. Then for x1, what is x1? X1 is like x naught plus h. So x naught is 0, h is 0.1. So your x1 is 0.1. Then what is y naught? Y naught you have already, sorry, y1 you have already evaluated here. So this is the value here. And then you have to calculate f of x1 y1. So this is like f of x1 y1. So here you substitute x1 is 0.1 and y as 1.1, you will get 1.2. And then you calculate your y2. Y2 is your like y1 plus h f of x1 y1. So this is f of x1 y1, you have substituted here. This is h and this is y1 and this is your y2. And what is your x2? X2 is your x naught plus 2h, and this is y2. From here you have written here, this is your y2. Again you have to calculate x and yn, f of x and yn. So 0.2 plus 1.22, you will get this. And then you use these values in your Euler's method, and you will get this kind of. So in this way you continue, and you will get this as a y10. So this is your y10, and y10 means your x10 is your 10, and this is your y10. So if you take more number of n, like instead of 10, if you have taken 100, then you have to do this thing 100 times, and then you will get a better value of y1. So then we have another problem. This dy by dx equals to x plus 2y, and here x naught is 1. Here x naught is 1, and y naught is again 1, and for x equals to 2 we have to find. Again we have taken n equals to 10. So 2 minus 1 upon 10, again h will be 0.1. So this is x naught, this is y naught, and this is f of xy. So f of x naught y naught is like 1 plus 2 time into 1, you will get 3 from here. And then this is the Euler's method, and you will get this is as your y1, that is value of y at 1.1. This is x1. So So the value of y at 1.1 is given by this 1.3. And in this way you continue, you will get the value at 2 like this one. Then we have Euler's modified method. So what we will do in Euler's modified method, like we have uh, it is same as Euler's method. The first step we calculate y1, y naught is known to us, and f of xy is also known to us. So here, then what you do in then each step, like you can see that we have already calculated here y1, and now what we do, we actually try to calculate the better value of y1. Like from x naught y naught, you are calculating y1, but you want a better approximation of y1. So to get the better approximation of y1, we will write this y1, this bracket 1. So that is we are trying to get the first better approximation of y1. So this is the modification in the Euler's method. Y naught plus h by 2 f of x naught y naught plus f of x1 y1, and this y1 is we take from the Euler's method. So we are getting the first updated value of y1. If you are like we the error is not satisfied by this first approximated value of y1, we again update this value of y1 by using second iteration. So in this again y naught plus h by 2 f of x naught y naught is same. Now we have f of x1, but now we use this value as an updated value of y1, and we will get a better approximation of y1, and in this way we will continue until our desired error accuracy is satisfied. So once we say that okay, this is like we are not interested in modification of value of y1, then we calculate y2. Again, if we want to modify the value of y2, so for y2 again we have to get its first updated value, second updated value, and when the like error criteria is satisfied, then you go for y3, and then you get a y3 first updated value, y3 second updated value. Like this we apply this Euler's modified method. So like this is the problem we have. We have to use modified Euler method with the initial okay, we have to find the value at y at 0 0.2 and 0 0.4, and this is our dy by dx, that is this is the definition of f of xy with this is the initial condition y at x0 equal to 0, and here we have to go up to 4 decimal places, that is we have to correct up to 4 decimal places. So first you identify the f of xy, so this is your f of xy, and then this is x naught. This is your y naught. So from x naught, you have calculated the value of x naught y naught. This is you have calculated the value of f of x naught y naught, and if you substitute here like x equals to 0 and y equal to 1, you will sorry y equal to 0 and x equal to 0, you will get 0 plus e raised to power 0, that finally 1. So this is the value of f of x naught. Since we are calculating first time the value of y1, so this intermediate we can generally we say that is the average of two slope. This is one slope and this is another one slope, or we say that mean slope also, but this is not required for the first step, because in first step we apply this Euler's method to get the value of y1. So to get the value of y1, we are getting here So the formula for this one is like y naught plus h f of x naught y naught. So here h we are taking 0.2, y naught is 0, so this is y naught, this is h, and f of x naught is from here, it is 1. So from Euler's method we are getting one value of y1, that is 0.2. So now we update this value of y1 using our Euler's modified method. So to get the updated value of y1, and since it is like what we say h equals to 0.2, so obviously your x1 is like 0 plus 0.2, so your x1 is 0.2, so this is your x1. So now with this x1 you calculate the value of f of x naught y naught. So what is f of x naught y naught here? Again this 0.2 plus e raised to power 0.2, you will get 1.4214. And this one is okay, this one is mean slope. Actually, so like if I write here, this is like f xn yn, and x and yn is like yn plus e raised to power xn. Okay. So now we are calculating the slope at the new point x1 and the new updated value of y1. That is, we are calculating here, we are calculating f of x1 and y1. So this is f of x1 y1. So x1 is 0.2 and y1 we have calculated here as 0.2. So this is the value of f of x1 y1. Now we are calculating here the mean slope. So how this mean slope is coming? If you see, the mean slope is this one. It is like h by 2, or you it is f of x naught y naught. So f of x naught y naught from here we will take from this step, because this is f of x naught y naught, and then we use f of x1 y1, and f of x1 y1 we will get from here. So this is f of x1 y1, and this is f of x naught y naught, and then we have to add these two and then divided by 2. So instead of having this 2 here, we can have this 2 in the division here like this. So here this 2 can be imagined here also, because it is in the division. So this is the like a mean of these two slopes. One is f of x naught y naught, one is f of x1 y1 with the updated value of this updated value of y1. So we have this h by 1 by 2 f of x naught y naught, this is from here and this is from here, and then we take their average and we will get this one. And now this with mean slope, the our method is like y naught plus h into, now we have here, we from here we are applying Euler's modified method, y naught plus h into like this 1 point mean of the two values, mean slope like this. So h into this, and you are getting the value of y1, but it is like updated one time. So that's why we have superscript in bracket 1. Now this will become the value of y1. Now we again update this value of y1. So you can see that still x1 is remaining the x1. Now we are calculating f of now we are calculating, this is f of x1 y1 1. It's like this, f of x1 y1 1. So why what is y11? Because it's the first updated value we have to use. So this is 2.2421. So 0.2421 is a like first updated value of y1, and then x1 is like 0.2 again. So y1 superscript 1 is 0.2421 plus e raised to power zero point 0.2, and this will be the this one. Again we have to take the mean slope. So in mean slope, you know that the first is always remain the f of x, not y naught. So it means we again write the value.
Initially put the hydrogen atom and chlorine atom in same level. Same level means हम ड्रॉ करके देखेंगे कितना एनर्जी है सब जो बंदा हो.
So we again take the value from here, like this is our f of x naught y naught here, this one. This one is actually our f of x naught y naught, and this is like f of x1 comma y1 superscript 1, that is first updated value. So this is like this one. So from here we have taken this slope. So the first slope is always remain this f of x naught y naught, and the second will change as per the updated value. So now we have this one as the mean of the two slope. Then again we write y naught plus h into this value, and we are getting y1, the second updated value of
Okay.
y1.
So
Again
here.
we modify it for x1.
Okay. So here, suppose this is in past version.
So if we are doing the again modification in it, so now we have this as a y2 second updated value. Now again your this x1 is 0.2, and then you here you are calculating
Here,
f
then what
of
happened?
x1 comma
That's why
y1 using your second
not
updated value.
participate in this.
So if you use this, because the definition of f of x and yn is this one, or f of xy is this one, so now y is actually y1, the second updated, 0.2463 plus e raised to power zero point 0.2, and finally this is this one. Then you have to take mean values, mean of the initial slope like f of x naught y naught plus f of x1 y1 second updated. So this is the second update, and this is f of x naught y naught, and this is finally this one. And then you use y naught plus h into the mean slope, and finally you have third updated value. Once you have third updated value, you can calculate fourth updated value also. So to calculate fourth updated value, again we use here this value as y13 updated plus e raised to power zero point 0.2, and you have this again with the initial slope and the current updated value slope, and then you have taken mean of it, and you have this as the mean of the slope, and then this is the fourth updated value of y1. And you can see that here the last four digits of these two, y1 third updated and y1 fourth updated, are same. So we will stop here for updating the value of y1. Now we again calculate the value of y2. Now to calculate the value of y2, we require this. Now this is our x1, and this is now this we are assuming that this is like our final updated or corrected value up to desired accuracy of y1. So we say that this is f of x1 comma f y1 4 is the our final corrected value. So for this value we calculate this, and we are having this as this f of x naught y naught. So now for this calculating y2, again we use our Euler's method. We are not right now having any slope here. So here the first value of y2 is also calculated using our Euler's method, and that is actually y2 equals to y1 plus h f of x1 comma
the hydrogen one state energy are equal
comma y1
because it is
4.
according to energy
So this formula we use, and this is actually our Euler's method. So to calculate the first value of y2, y2 means like we are calculating y at zero point 0.4. So its approximation is y2. So you calculate by using your Euler's method y1 plus h f of x1 y1 fourth updated value, and you can calculate like y1 is this one 0.2468 plus 0.2, and this is your f of x1 y1 fourth updated, and this is the value of y2. So once you have the first value of y2 using your Euler's method, now you correct the value of y2. So to correct the value of y2, here this is your like x2, because h is 0.2 and x naught is 0. So x naught plus 2h is 0.4. So this is your x2. So now you have to calculate.
And the hydrogen atom values of vital are more than this. So that's why
Now you have to calculate the first updated value of y2 using your Euler's modified method. So for this, I calculate first f of x2 comma y2 using this value, and this I will get, and then I take the mean slope. So mean slope, now earlier we are taking like x naught y naught when we are updating for y1. Now we have x1 y1. So here we have x1 y1. So this remain the same. So f of x1 y1 remain the same, plus f of x2 y2 is this one. So this is f of x1 y1 4. This is remain the same for all modified step, and this like f of x2 y2 we are getting in the current step is this one. So this is the mean slope. Now to get the value of y2 first updation, you will write here y2, and y2 is your here this one, sorry y1, it is actually y1. So y1 is actually y1 4, that is 0.2468. So it will also remain the same, plus h into the mean slope. This one is the mean slope you have calculated here, and after simplification you are getting this is the first updated value of y1. Now you want to modify this again. So for modification again we have to calculate f of x2 y2 and first updated value. So if we
so one is two is done. So another
y2 first updated value. So if we calculate, this is y2 first updated, that is 0.5964 plus e raised to power 0.4, and this is the your value. Again you have to take the mean slope. So here the initial point because it's now shifted to this point, so this slope remain the same, 1.4682, and this is the updated slope at the updated value of y21, and then we have taken the mean, this is this one, and then we use the formula like y1 plus h into the mean slope, and you have the second updated value of y2. Again if you want to modify it, we have to calculate this f of like x2 y2 second update value of y2, and then we will get this one. Again we use the same slope here for f of x1 y1, and this slope like from updated value of y22, and then their mean, and then we get the value of y2 third updation by using this y1 plus h into the mean slope.
zero.
Then you want to again update it like this. Then you calculate f of x2 y2 third updation. This remain the same. This remain the same, and this is like from the current updation, and you will get this y24. Similarly, you will get next one, uh, fifth updated value of y2. For fifth updated value of y2, we can see that they are matching up to 4 decimal places. So we will stop here, and we will assume that this is the final value of y2. So and y2 actually, you know that y2 is actually y of x2, and that is actually y of 0.4. So this is the y at 0.4, and this is y at 0.1, 0.2, and this is the value like when we have this one fourth updated, because these two are same. So this is the way we apply our Euler's modified method. So once again we have another problem. Solve the following by Euler's modified method. This is our differential initial value problem. Dy by dx equals to log of x plus y. Y0 equals to 2, and we have to calculate x at 1.2 and 1.4 with h equals to 0.2. So in this case, our x naught is like 0, and y naught is like 2, and the common step is also given here 0.2, and then we have to calculate the value of y at 1.2 and 1.4. So first we calculate x naught. X naught is given 0. Then we calculate f of x naught to y naught, and this is actually this one. And then we use Euler's method to get the value of y1, like y naught plus h into f of x naught y naught. This is the y1 value. And then we calculate the updated value of y1. So here we are calculating again x naught, sorry, not x naught we know, x1 y1 we have obtained from the recent step is this one, and then average of this plus this, you will get mean slope, and then you apply your Euler's modified method, and you will get this first updated value of y1. So here like they are matching like two decimal places, or we will stop here because it depend on upon our criteria of updating the value of y1. So here we stop here because we have to go like till 1.2. So if we go for 4 digit accuracy, it will like take lots of time. So like if like if first digit is matching after decimal, then we will not, we are not updating the value of y1. So this is like if this is the accuracy of our calculation, so we will get this is our first updated value, and this is matching from y1 at first decimal place. So we'll stop here, and then we will calculate y2. So to get the y2, we have this one is x1, and we will calculate the value of this f of x1 y1 1 updation. And since we are calculating first time value of y2, so we calculate it by using Euler's method, and then we update the value of y first time by using Euler's modified method. Here we again taking that this is like a better accuracy because this is the matching with the first decimal place. So we will assume this one is the updated value of y2 in the first iteration itself. So we'll calculate y3. So to calculate y3, again we calculate f of x y1, not y1, f of x2 y1 y2 y21, and then we have this value, and then we use Euler's method to get this one, and then we again update it with Euler's modified method, and in this way we'll go. And finally we have these values, and again we have updated this value for first decimal place. So we'll stop here, like 2.656 is the value of y 1.4. So we are taking here one decimal place accuracy. So this is the way our Euler's modified method will work. General's method we will discuss in the next class. And so
Yeah.
yes, attendance 1,
Present, sir.
2,
Present.